All right, let's start with the first one first. It's a little simpler, I think. So in the first one, we have 0 equals sum I, and there's 2's on every term here, so we can just divide by 2. Cancel that. Oh, I'm like looking down at the iPad and I keep on coughing. Okay. All right, so we have negative yi, put this in parentheses here, plus beta naught hat plus beta 1 hat xi. I want to solve for beta naught hat here. We can isolate one of the variables. So recall that we can distribute the sum across across a sum. So that'll be sum I. And also we can pull out any constants to the front of the sum. So it'll be negative sum I yi plus here, just sum I beta naught hat, and then plus beta 1 hat sum I xi. This means that we're going to sum, so this is for, I equals 1 to n, so we're going to sum this number. Beta naught hat doesn't have an I anywhere in it, so we can think about it as a constant, which is why I pulled, beta 1 hat out here. If it doesn't have an I, it's a constant. So it just means that we're going to sum up this number n times. So this is actually going to be equal to n times beta naught hat. Hopefully that makes sense. So let's see. We're going to bring this term out to the other side. So we're going to get negative n beta naught hat is negative sum I yi plus beta 1 hat sum I xi. Let's divide the whole thing by negative n. And so we'll have beta naught hat is sum I yi over n plus, minus beta 1 hat sum I xi over n. And what is, so what is this term? What is this term? If you sum all of the data and then divide by the number of observations, you'll get the average. So this is actually y bar, beta 1 hat, x bar. And that's a nice, succinct equation. Still has our second unknown in here, so we still have more work to do, but that's a pretty nice formula for beta naught hat.